In this video, we're going to work on our implementation to the MergeSort function. Our goal for MergeSort right here is to recursively subdivide this input array. So we're going to split this thing into two, and then we're going to take both the halves and pass them back into MergeSort. So let's write out the code for that first and make sure that we've got a good idea on exactly how it works. So inside of here, we're going to first check to see if the array has one element inside of it. Because remember, if the array only has one element, that means that we cannot subdivide this array anymore. So we'll say if array.length is equal to 1, then just immediately return the array. So there's no other work we can possibly do here. This thing is as small as it possibly can be. And then underneath this is where we'll start to put down some logic to divide up our array. Notice that there is a return statement inside the if statement. So if we hit the if statement successfully, then we're not going to execute anything else inside this function. The next thing we're going to do is divide the array into two equal halves. The first thing we have to do to accomplish that is to determine the center point of the array. So we'll say const center, or the center index, is going to be math.floor array.length divided by 2. So imagine this calculation right here. If we have an array of length 4, we will divide 4 by 2. We'll then round that down, so we'll stay at 2. And that means that our index of the center point of the array would be at index 2, which definitely makes sense. Let's imagine if we have how about A, B, C, D, like so. If we got the center point of this thing, it would be at index 2. So 0, 1, 2. So C would be our center point right here. Now this might not exactly seem like it really is the center point, but just wait a moment until you see exactly how we divide this array into two halves. So to divide the array into two halves, we'll set up the left half is going to come from array.slice, everything from 0 to center. Now here's the key thing. Remember how slice works. With slice, we take everything in the array from element 0 all the way up to, but not including the center value right here. So if we consider A, B, C, and D again, and we called slice from 0 to 2, well, here's index 2. So we take everything from index 0 up to 2, but not including 2. So the left half right now would be simply A and B. Then to calculate the right-hand half, we would do array.slice and only pass in center by itself. Array.slice with center is going to say take everything from index 2 all the way to the end of the array. So in this case, it would be elements C and D. So now at this point, we have clearly two separate halves here. Now the first thing I want to do with these two halves is recursively call the MergeSort algorithm. So we're going to call MergeSort with the left-hand side, and we're going to call MergeSort with the right-hand side. Now if we ran this function right now, if we executed this code, I think you could agree with me that we are going to recursively subdivide an input array into separate equal length halves until eventually both those halves have a length of 1. And at that point, we would just return the array and we will stop trying to divide it into any further halves. So hopefully this part, not that bad. Okay, we can see how this recursion is working. Here's where things are going to start to get a little bit weird. So here's the recursion part. Let's write out the code for the recursion part and we'll talk about exactly what it's doing. I'm going to put both these recursive calls on the same line and split them with a semicolon. And I'm going to pass it all to the merge function, like so. And then I'm going to return the result. So you should have return a call to the merge function, the left and the right. Let's save this right now and see how our tests are doing. So I'm going to save the file. I'll check out my terminal and you'll notice that the MergeSort function is now working properly. So it might be a little bit of a surprise that it's working right now, right? Personally, it is to me. I feel like everything in this solution, everything in merge, this all makes sense to me personally. Everything in MergeSort up to like right here makes sense to me personally. And it's this line of code right here that makes life really, really challenging. That's my personal opinion. I think that the easiest way to understand this line of code right here is to consider what would happen if we called the MergeSort function with an array of length 2. Because in that case, we can very easily imagine every line of code and how it gets executed. So let's take a look at another diagram that's going to walk us through the MergeSort algorithm, and specifically all these different function calls when we only have an array of length 2. All right, so here's our diagram right here. So the first array that we're working with, like the array that we are trying to sort, is going to be containing the values 97 and 0. So we pass this array right here to MergeSort, the MergeSort function that we just wrote. So let's walk through the code in that case. So we pass in with 97 and 0 as the array. That does not have length 1, so we definitely come down here and divide the array into two separate halves. Left would then contain the value 97 inside an array. So we could say right here that we would have something that looks like this. And then the right-hand side would be something like that. We then take 97 and pass it back into MergeSort again. So we're going to take only the array containing 97 and pass it back into MergeSort. When we do that, so here's right here, we would have, as the argument, we would have inside an array 97. We're going to look at the length of the array, and we'll see that it is of length 1. So we return the array immediately. So the initial function call to MergeSort, we divided it into 2. We got 97 for left. We passed it into MergeSort. It did absolutely nothing else, and so that follow-up function call ends up with just 97, like so. Then for the other half, for array 0 right here, we pass that back into MergeSort, and MergeSort immediately goes to the if statement right here. We realize that it has a length of 1, and so we immediately return the array. And so again, with the original function call, with the first initial function call right here, we can imagine that we're back up here. We passed in 0 to MergeSort. It did absolutely nothing, and so we are back with just the array containing 0. So now we can kind of imagine that right here, passing in 0 to this thing leaves us with overall 0, like so. And so we then call merge with 97 and 0, and the result is a single merged array, which would be 0 and 97, like so. And we return that value, and that's it. So hopefully that adds a little bit of clarity to how the recursion is working here. Again, I think it's really tough to visualize the recursion in this case, but to get a really solid idea of what is going on, you can imagine this MergeSort function getting called with an array of length 2. And then you can much more easily walk through everything that's going on here, and it'll give you a much better idea of how this is working. If you want to get really have some real fun, I suppose, maybe try imagining what would happen if you called MergeSort with an array of length 3 or an array of length 4, one or the other. And then that's when some of the recursion stuff is going to get even more clear. But that does take a lot of time and a lot of concentration to walk through, and so I don't think it's really probably the best use of time inside of a video, because honestly it's something that you kind of have to go through yourself and keep track of all the different variables that are floating around. Okay, so that is MergeSort. Now, MergeSort, I'm going to tell you, I'm not a big fan of it in an interview setting, just because this recursion stuff is rather challenging to come up with on your own. This is a great example, just like when we were talking about Fibonacci earlier. With Fibonacci, it's kind of tough to imagine someone coming up with that recursive solution without previously seeing it before. And I think that goes in triplicate for the MergeSort function. I think that if you sat down in an interview, having never seen MergeSort before, and someone said, hey, let's put together MergeSort, I can't imagine a person who would say, okay, like, let me derive the solution to MergeSort right now without ever seeing it previously. So if you ever see MergeSort in an interview, personally, I think that it's really a test to see whether or not you literally memorized the solution. That's what it's really testing. It's not testing whether or not you can figure it out on the fly. Anyways, enough ranting from me. So that is MergeSort. Let's take a break and now continue in the next video.